Welcome to Bytes of Code. At this point in our tutorial, we have a full working tic-tac-toe game. So great job if you followed the tutorial all the way through. At this point, we're going to do a recap on every single line we use in order to make the tic-tac-toe game. But right before that, let's add two cool things into our game. The one thing I want to do is ask the user if they would like to play the game again. I'm going to do this right here after I check is there a winner, and after the tie game check I'm going to put in a condition. If is there a winner variable is equal to true, then I'm going to ask the user if they would like to play again. I'm doing this inside the loop because I actually want to flip is there a winner variable back to false if the user decides to play again. So we're going to kind of do a little bit of shorthanded if statement with an input. We're going to, in our if statement, we're going to do the input statement, asking the user play again. And we're just going to tell them they type in yes or no. And if this input statement returns, which is basically the user typing in yes, then we're going to switch back the is there a winner back to false. I also, because we already have a dictionary that's full of values, I'm going to go ahead and clear board. We have a function that does this already. I'm just going to use it. And also we have a printBoard. So I'm going to show the board being printed. I'm going to show it being cleared. So again, a recap, we're doing if there is a winner, we ask the input, play again. That's what we tell the user. And if their input is equal to yes, then we're going to go ahead and switch back that is there a winner, Boolean, clear the board, print the board. And let's see what that looks like. This actually does another thing too. So we have X going to make the win. X is the winner. User says yes, they would like to play again, and we still have our player swap, and you can change this around, but right now we basically are giving O the chance to go first now. So we have a player swap still of who goes first. This is line 123 to 127 is still being used, and so now let's let O win. O is the winner, and we can play again, and this is now our loop. We have a clear board, we printed the board so the user can see it's cleared, and we can start playing the game all over again. Let's do one more thing that I really like to do. Right now at the beginning of our tic-tac-toe game, we just say tic-tac-toe. Let's take that out and swap it for an ASCII art. Usually for ASCII art, I just Google text ASCII art converter. This one's pretty good. This one's got just a lot of options. It's really easy just for me to copy it. And I'm going to do this for our title. So print statement, and it is 3 quotations. And then you could go ahead and just paste it, the ASCII art, after copying it. And now we have our tic-tac-toe game. I think this is way too far down. Let's go ahead and bring this up a little higher, and we'll lose these new lines. And that should be a little better. Yeah, tic-tac-toe. So now that we have our entire game, we even have some move detection. We see O is trying to go to a space that's already being occupied. Now that we have our entire game, let's go ahead and pick it apart, every single line, to see what it's doing. Let's go ahead and start with the board. This is line 14. This is the first piece of code in our Python game. This is a variable that is a dictionary. So that's actually what we're using when we see this grid. This is actually just a dictionary being printed out, kind of in a fancy way with some graphics to mimic a tic-tac-toe board. The way you know it's a dictionary is because you can tell pretty quickly from the squiggly bracket. If it's a list, which can look a little similar to a dictionary, it would be a square bracket. So lists you can quickly identify with square brackets, but we can tell that this is a dictionary One of the reasons is because we look and we see it's a squiggly bracket. We see we have 9 key value pairs here. The keys are a string, and in this case the strings are 1, 2, 3, 4, 5, 6, 7, 8, 9, and the values at the very beginning of this dictionary are also 1, 2, 3, 4, 5, 6, 7, 8, 9. And the reason that we have them set to a key and a value of 1, or a key of 1 and a value of 1, is because we want to print out for the user for the very first time this board, kind of like a template for the user, so the user knows where they're going. They identify the space number 2 and they know immediately where they're going if they were to type in number 2. That's an example. Pretty soon after we display this board, we actually end up clearing every single one of these values, so it would look something like this as an example. That's how it would look like soon after we display the board for the first time to the user. So this is our dictionary. 9 keys, 9 values. We have our function. This is kind of the first time we're using a function in one of our tutorials. So the function is used with the 3 letters DEF. That is defining a function. So that's how you start to create a function. After that, it's going to be your function name. In this case, our function is named printBoard. Then you can choose to have parameters, or you can choose not to have parameters. In this case, we've chosen to have a parameter. The name of this parameter is board. The name can be whatever you want, but the important part is that we know that a dictionary is this parameter. After we declare our DEF, function name, parameter, we end our function with a colon and make sure that the next piece of code is tabbed, because if the next piece of code wasn't tabbed, we would get an error. Unexpected indentation, spacing, something's wrong. We just need to make sure that the next piece of code is tabbed. That means that actually this is the code that belongs to the function, and we can tell pretty quickly here that this is our function because all of these lines are tabbed underneath our printBoard function. Line 27 through 31, actually we're just printing out the board. This is actually this area right here where we print out 1, 2, 3, 4, 5, 6, 7, 8, 9. We're printing out values from the board to show to the user. Line 27 is printing out the first row, 1 with a, we can call it a separator, which is just a pipe sign. And then we print out the board at position number 2, or we can say the board with a key number 2, then another pipe sign, then the board, the key number 3, and that's where we end it there for the first row. That would print out this top row here. The next thing we do, the next line, is print out kind of like a divider. So again, this is just to mimic the Tic Tac Toe board, just to make it look kind of similar to a Tic Tac Toe board. Then we do the same thing with line number 29, printing out the keys 4, 5, and 6, printing out their values on our dictionary that's being passed in as a parameter. Line 30 is, again, a divider to mimic a Tic Tac Toe board. We're not using any variables in line 30 or 28. Line 31 is doing the same thing, is printing out the key, we're printing out the values in our dictionary with the keys 7, 8, and 9. So all this function is doing is opening up our dictionary and printing it out. That's all what this function is doing. We're not even assigning any values to our dictionary in this function. Our next function, line 33, is clearBoard. This also takes in a parameter we've named board, and we know that this is a dictionary that we're passing in. And for every item in our dictionary, what we're going to do is just set that item to empty space. Just set it to an empty space. It's actually just one space. Technically, we're setting it to one space, and this is clearing the board so that when the user actually starts playing, they don't see the numbers, but everything is empty, we can call it, on the dictionary. Technically, the dictionary still has values. This is a value that belongs to our dictionary at that key location, but we're just using this in order to present to the user empty space to show that these are the possible areas that we can play on the Tic Tac Toe board. That is our function clearBoard. Check for the winner function, line 37. This is kind of a tedious function. We take in two parameters, the board, which is going to be a dictionary, and we also take in who just went, which is going to be the string of the player input, or the current player. This is going to be the string of the current player. This is important because we're going to be checking to see if the current player has a tic-tac-toe win, has a tic-tac-toe pattern, or are occupying certain areas of the dictionary that would qualify as a win. For example, line number 40, we check the top row, 3 across. We check position number 1 on our board, position number 2 on our board, and position number 3 on our board. We do this in one if condition. We check if all 3 of these positions are equal to the current player. Let's just say X is the current player. If they're all equal to X, then we know that X has 3 across, so they're the winner. So we print to the user, the person who just went, that's the variable who just went, is the winner, and we return true. Line number 42, return true, that's going to stop the rest of this function from running. The rest of this code in this function will not run. We return to the person or to the area, the code that called this function, and we give them the result true. And later on, we'll identify why that's important, because this return true basically tells us that, hey, someone won. And that's going to be a flag to stop the loop later on. We do this same logic with the top row with every row. We do it with the middle row, which are keys 4, 5, and 6. Checking again if they're all equal to the current player, the person who just went. We do the same thing again with line number 48, checking the bottom row, 7, 8, 9. Those are the keys on our board, 7, 8, 9. Are they equal to the player who just went? If they are, then we know that that player wins. We also have to check the columns, because you can get 3 up and down in order to win in tic-tac-toe. So we check 1, 4, 7. We check columns 2, 5, 8, or the keys in our dictionary, 2, 5, 8. And we also check keys in our dictionary 3, 6, and 9. That's going to be the right column. And there, even though we're checking the rows and columns, there's still another way a user can win, and that's diagonal. So we're checking from left to right. That's going to be keys 1, 5, and 9. And if you look at our board, you can tell right here, 1 is the top left, 5 is the middle, and 9 is the bottom right. And we also check from top right to bottom left. That would be key 3, key 5, and key 7. If these keys on our board are equal to the current player, or the player who just went, then we return true. This line 74 is hit if none of these conditions return true. So if we check top row, hasn't returned true, mid row has not returned true, bottom row, left column, mid column, right column, none of the diagonals have returned true, then what we will get is line 74. We will eventually reach line 74 to return false. Because remember, even if we got a diagonal right here, let's just say we have somebody that has a top right to bottom left diagonal win, this line 73 would return true, and line 74 would not be hit. Line 74 would not run if any of these return trues were hit. So if none of the return trues were hit, then finally we get to line 74. We've checked all the possibilities. We can safely return false, meaning that nobody has a win. So that was the function, check for the winner. Let's take a look at another function, isValidMove. isValidMove takes in a board, which is a dictionary, and where the user just went. This is going to be a string. This is going to be the user input. Usually you might look at this and say, maybe the user typed in 1, so wouldn't it be an integer? Well, because it's an input, this 1 to Python is actually a string, even though it's a 1, because it's an input. If it is an input statement, let's take a look at an input statement. Right here, input, this is going to return you a string. And you can see it there at the top replit, kind of giving us a little hint. It says input prompt any, and it shows a dash with an arrow kind of, str. That means that this function input will return us a string. So that is what we're actually going to be expecting as a variable type. isValidMove takes in a board, dictionary, and a string. If the board, the dictionary, at the position where the user just went, that's the key that we're using, if it's not equal to an empty string, then we return false. And what is this telling us? This is telling us that we're checking to make sure that the board is able to go at that position. We don't want X to go at a place where O went, or we don't want O to go at a place where X already went. We only allow moves if the board is empty space at that location. So for example, at this position number 5, if the user were to type in number 5, let's actually do it. Let's try it. The user would type in number 5. We check to make sure that's an empty space, and if it is, then we return true. We say it's a valid move. But it's an invalid move if the board where the user went, let's say O is going to go at position 5, it's not equal to an empty space. So because the board at position 5 was not equal to an empty space, we return false. In this case, the board at position 5 would equal X. That's the value that we're assigning in that dictionary. We have another function here at line 83, isBoardFull. Takes in a board parameter. This is the name of our parameter, board, which again is a dictionary. This is similar to our clearBoard, but what we're doing is we're just seeing if the board has any available space for the user to go. We use this specifically because we're going to be checking for a tie game, and we use this function. So we loop through our entire dictionary, and if any of the keys have an empty space, that means that there's a possibility to go there. So we return false. The board is not full. But again, if we've looped through all of this and we still haven't hit this return false, that means we will hit this return true, meaning that we have looped through all of the dictionary, we've looped through all of the board, and there is no empty space. So we can return true, the board is full. Line 90, we are starting to actually play the game. We start with our title. Line 100, this is our Boolean that's going to control our while loop. We're going to use this to run the while loop until this is true. When is there a winner is true, then we're going to know to stop our while loop, or our while loop does that automatically. Line 104, we're actually showing first the board to the user. That's what we're showing here. Right after we show the board to the user, in this example, we can see actually the board 1, 2, 3, 4, 5, 6, 7, 8, 9. We clear the board because we only want to show it for this time to show the user where they need to go, what they need to type in order to play, and then we can clear it. We start with the current player X. If you want, you can switch this to a different current player. You can even switch this to a different letter, but we want to just have somebody go first. So we have X go first. Line 109, while is there a winner is equal to false. Remember, the two equal signs is saying is it equal as a question, and the one equal sign is saying it is equal as a statement. So this is asking a question, is it equal to false? If is there a winner is false, line 111, we start to use our while loop. We ask the user your move, and we present the current player. We also learn about F strings actually in this tutorial. So instead of actually putting commas or plus signs to add to our string, what we're actually doing is just putting an F at the front of our string. This is telling Python that we want to format this string. This is kind of going to be a special string. And we use a variable in squiggly brackets to insert into our string. And that's what's going on here. So our user move is going to be whatever the user typed in, 1, 2, 3, 4, 5, so on. First, we check if it's a valid move. And we went through this function already. If it's not a valid move, this function will return false. Then we say, again with our F string print statement, current player, what are you doing? Line 114, kind of a new line also. This is continue. What this does is this stops the rest of the code and it jumps right back to the start of the while loop. So with this continue, none of the code underneath it will run in the while loop. We start the while loop all over again. So we continue to ask the user, in this case, your move. But if they've put a valid move, that means isValidMove returned true. It's a valid move, so we do not hit any of this code, line 113, 114. We continue with the while loop at line 115. And line 115 is very important because this is actually when we assign the X or the O to our dictionary. We open up our dictionary, the board, and we open with the key that the user typed in. In this case, let's say the user typed in 5, so the board at position 5 would now equal the current player. And let's do a little visual of this. So the board at position 5, because this is what the user typed in, so this is the key that we're opening, would now equal the current player, which at the beginning of the game would be X. And this is kind of how our tic-tac-toe would start to pan out, depending on how, of course, the user was playing. This is kind of how the user would be entering data into the dictionary as they're playing. So actually when the user types in the number, they're actually typing in, even though they don't know it, a key to our dictionary. So let's continue. After we assign our dictionary value, we print the board to show the user that something's changed in the dictionary. In this case, our print board looks like this. The user typed in 5. Then right after we print, we check for the winner. Is there a winner? If there is a winner, then we will get a return from the checkForTheWinner function, a true. Line 120, we're asking an if condition for a tie game. If the board is full, function equals true, and there is not a winner, is there a winner variable equals false, then we know that this is an equation that can only mean tie game. The board has all been filled up, there are no more moves, but there is not a winner. We tie game and we break. And what does this mean, break? Break means that we actually stop our entire while loop. So continue actually would go to the beginning of the while loop and start over again, whereas break will exit the while loop completely. But if there's no tie game, this if condition isn't hit, then we still will be checking if there's a winner, because if there's a winner equals true, we ask the user if they would like to play again. And if they click or if they type yes, we switch as their winner back to false because we want to continue to loop. And then we clear the board and print the board in order to kind of reset the game. Our very last couple lines, line 131 to 134, is going to just be switching the player back and forth. In this case, let's pretend it's our first time playing X plays. Then by the time we get here, current player is equal to X, so we assign current player equal to O. Then the next time we would play, we would notice that the current player is equal to O, so we assign the current player equal to X. And this is switching the current player. It's kind of flipping back and forth. It's very important to note here that in line 133, we're using an elif, because that means that once this condition is hit, we do not run this condition. For example, if we have an if instead of an elif, current player is equal to X, we assign current player equal to O, then we would run this one, this if condition, line 133. Current player would be equal to O because we just set it in line 132. So if current player equal to O, we would set it back to X. And basically it would reverse what we were trying to do. If we put an elif, then we make sure that once this if condition hits, line 133 if condition will not hit. So only one if condition would be hit when we use an elif in this case. So that's why it's important to use an elif instead of an if in this case in line 133. And that is our tic-tac-toe game. I thank you guys so much for watching. I hope that you really enjoyed what you're learning. If you have any questions, please Don't be afraid. Put them in the comments section. Something not working, something you're confused on, I will reply to you. Thank you so much again for watching this video. If you enjoy it, please give me a like, and I hope to see you guys at the next video.